to Fascinating Frontiers, episode 142 for July 25th, 2026. Here's your space and science briefing. Astronomers report the first strong evidence for an exomoon orbiting a planet 73 light-years away. SpaceX's Starship launched from Starbase, Texas, deployed 20 next-generation Starlink V3 satellites, and achieved a controlled splashdown in the Indian Ocean. The Starship upper stage successfully released an initial batch of the larger, more capable Starlink V3 spacecraft during the flight test. These satellites feature upgraded power and communication systems compared with earlier versions. Deployment marks the first operational use of the new Starlink generation on Starship. The satellites were placed into their target orbits after the upper stage completed its primary burn sequence. The next-generation spacecraft bring expanded onboard systems that support greater data throughput once operational. This deployment integrates the new satellite design directly into the ongoing constellation refresh. The vehicle performed a banking maneuver that rehearses the approach profile needed for future tower catches at Starbase. This flight addressed issues seen on the previous test and returned extensive data on thermal protection and propulsion performance. The upper stage re-entered Earth's atmosphere ahead of the Indian Ocean landing, while the booster executed its own recovery sequence. Remember, the show covered Starship development on EP 141. Today's test moves the program forward on the open questions of rapid reuse cadence and orbital refueling demonstrations. While Starship pushes hardware boundaries, astronomers are using existing telescopes to push the boundaries of what we can detect around other stars. Astronomers using the Very Large Telescope in Chile observed repeated gravitational tugs on a planet orbiting the star CD 352722. The companion object has a mass close to Jupiter's, yet follows an orbit that challenges standard formation models for both planets and moons. The detection relies on transit timing variations measured across multiple epochs rather than direct imaging. The system lies in a region where the host star's properties differ markedly from the Sun, adding another layer of complexity to the interpretation. Follow-up observations with additional facilities are planned to confirm the signal and refine the mass estimate. To understand how such a signal is extracted, here's a quick look at the technique itself. If Earth's year were compressed into a single hour on a clock, the gravitational tug from a moon the size of Jupiter would shift the planet's arrival time by several minutes across successive orbits. That tiny delay accumulates because the moon and planet orbit their common center of mass, so the planet does not cross its star at perfectly regular intervals. Astronomers measure these cumulative offsets over many transits with ground-based spectrographs that time the events to within seconds. At 73 light-years, the signal is detectable only because the moon's mass is large enough to pull its planet by tens of thousands of kilometers during each orbit. The same technique has already uncovered dozens of non-transiting planets, yet applying it to moons remains rare because the timing amplitude is smaller and requires years of continuous monitoring. We can now see the effect clearly in the CD 352722 system. But nobody yet knows whether the moon formed in place or was captured after the planet migrated inward. From one surprising detection to another, researchers have also turned the Event Horizon Telescope array back on the famous black hole in M87. Researchers combined 2018 Event Horizon Telescope and Global Millimeter VLBI array data to produce the first spatially resolved dual-frequency study of the M87 star accretion flow. The images reveal temperature and density gradients across the inner disk that were previously unresolved. The work shows how synchrotron emission changes with frequency near the event horizon. The dual-frequency approach isolates regions where magnetic fields and particle energies shift rapidly. Additional multi-frequency campaigns are expected to map magnetic field structure in greater detail. While some teams chase the extreme, others simply watch the familiar sky change with the seasons. On July 25th, the Great Square Asterism, formed by Algenib, Markab, Sheet, and Alpheratz, becomes prominent in the eastern sky after 10:30 p.m. local daylight time. Only 3 of the 4 stars belong to Pegasus. Alpheratz is the brightest star in Andromeda. Observers can use the square to locate other autumn constellations as they climb higher through the night. The Moon's passage near Antares earlier the same evening provides an additional reference point for locating the rising square. Back on the exploration front, NASA has named the target region for its next crewed lunar landing. NASA's Artemis IV mission plans to land astronauts in the Moon's polar region to study water ice deposits and test resource utilization. The site selection supports long-term surface operations and future gateway rendezvous. The polar terrain offers access to permanently shadowed craters where ice may remain stable. Remember, the show covered Artemis on EP 141. This announcement advances planning for crewed landing schedules and lander readiness. NASA leadership is also publicly tying that future to one specific vehicle. NASA's chief highlighted Starship's potential to transform access to the Moon and Mars through its large payload capacity and reusability. The comments tied directly to ongoing collaboration between NASA and SpaceX on Artemis lunar lander development. The administrator noted the vehicle's ability to deliver substantial hardware in a single flight. Remember, the show covered Starship on EP 141. Today's statement underscores the vehicle's role in the crewed Mars timeline. Meanwhile, a smaller but still notable discovery has astronomers rethinking formation models again. A body with nearly Jupiter's mass was detected circling a brown dwarf 71 light-years from Earth. The object sits at the boundary between planet and star classifications and does not fit standard formation scenarios. The discovery, published in Nature, raises questions about how such companions form around substellar hosts. The system challenges existing definitions because the central body lacks sufficient mass to sustain hydrogen fusion. On a more practical note, regional industry is quietly supporting the broader space economy. A company in North Texas supplies components and services that contribute to the expanding private space sector in the state. Its work supports both launch vehicle development and satellite manufacturing efforts centered around the growing Texas aerospace corridor. The firm's contributions help sustain supply chains for multiple commercial and government programs operating from the region. Farther afield, modeling work continues on another planet's climate. The Mars Climate Modeling Center at NASA Ames runs global climate simulations to study dust, water, and carbon dioxide cycles on the red planet. The models help interpret data from current orbiters and rovers while preparing for future landed missions. Outputs feed into long-term climate history reconstructions that compare present conditions with ancient epochs. The center's work integrates observations from multiple spacecraft to refine predictions of seasonal and regional weather patterns. One of the networks that keeps those missions talking is itself under threat. One of NASA's key antennas used for communicating with distant spacecraft is threatened by wildfire activity. Loss of the facility would reduce tracking and data return capacity for multiple ongoing missions. Engineers are assessing protective measures and backup options that could maintain contact with probes at the edge of the solar system. The antenna forms part of the network that relays commands and science data from Mars, outer planet, and heliophysics missions. While hardware faces earthly hazards, NASA continues to fund foundational research. Amendment 66 to ROSA's 2025 confirms the due date for Step 2 proposals under the Heliosophics Foundational Research Program. The solicitation funds studies of Sun-heliosphere planetary interactions across scales. Selected investigations will address fundamental drivers of space weather and plasma processes that affect both Earth and other planets. Proposals must demonstrate how the work advances understanding of energy transfer from the solar interior to planetary environments. The agency is also asking the community how it might run future prize competitions. The agency released a request seeking community input on the structure and focus of a potential new prize competition. Responses will help shape challenge areas that could accelerate technology development for future space science missions. The request invites ideas on prize topics, eligibility rules, and evaluation criteria that align with NASA's science priorities. Input gathered will inform whether a new competition is launched and how it might be administered. Keep an eye on follow-up observations that could confirm the exomoon candidate around CD 352722. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Nira Network. Links in the show notes. And before you go, this show is part of the Nira Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. SpaceX Daily, the daily companion for following SpaceX as a public company, from Starship to the stock ticker. Find every show free at naranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at naranetwork.com/data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.